we'll start with, say, the -f option. PS -f gives us essentially the same information, but it gives us some extra details. Now, I didn't actually mention what those details actually are. The first one, so we'll go back up here to the original PS command and we'll find out that this is our process ID. This is our unique number in the range 1 to 30,000, often known as our PID. So I've got 16,029 is the process ID for my shell, for example. Notice that that is the same process ID still hasn't changed. The process is still running with the same process ID, but the PS is different to this PS. This was 16,378 and this one 16,490. So in the intervening time, 112 programs have been started. Or should I be more precise, 112 processes have been started. Anyway, other columns involve TTY, that's the terminal that you're running the process on, and the amount of CPU time in seconds that process has used up. That will enable you to determine how much of a load your programs are placing on the system. The extra columns that you get with the -f command include the PPID, which is the parent process ID, or if you like, the process ID of the process that started this particular process. The PS -f command, which is 16490, was started by 1629, and 1629 is the shell. So the shell started the PS, which is what you would expect. The shell, incidentally, was started by process 16028, and we don't know what that process is because it's not part of this list. I'm not sure what the C column is for. S time means the time that the process was started, again the TTY, and again the time, and then now the command is given with its full command line options, PS -f. So there's a subtle difference between this column here command and this column here command. You get the command line options here, but here you don't. And the little minus sign there simply indicates that this is a login shell as opposed to a shell you might have started manually. Let's have a look at PS -L. You get a completely different set of information, and to be honest, I don't know what a lot of these things are. I don't know what F is, I don't know what S is. UID, well, that's the same as mVirtue, just displayed as a number. So my user ID on this system is 3040, always was, always will be. Again, the parent and current running process IDs. I don't know what C is, I don't know what pry is, I don't know what NI is, I don't know what ADDR or SZ or WCHAN are, and the rest we know. Now we could use the PS-U command to find out all the processes for a given user. Let's find a list of users using the who command. So we could now say choose one of them. We could say PS-U, and we could choose the user, let's say Sartori. Sartori. I have no idea who that person is, but I'd like to see what they're doing. Okay, well, they're running a couple of shells, a couple of bash shells. They're also running 3 copies of the program called bitch-x, whatever that is, and LFTP. LFTP is not associated with a terminal. If you don't know what that means, don't worry. We could also use the -f option in there as well, PS-FU, Sartori, and we get the same details, but we get some more information. So we could see, if you like, the command line for those bitch-x programs. Finally, I'll do a PS-E to find out all of the processes that are running on the system, and they're all scrolling past now, and there's quite a lot of them. I might do that again, PS-E, and this time I'll pipe the results to WC-L to find out exactly how many processes are running on the system, including, of course, the PS-E and the WC-L, and we find that there are 209. Okay, so, and then you can use that with grep, for example, if you need to find out all of the people that are running, say, vi. So you might do PS-E, pipe to grep vi, and it'll show you only the ones that have the word vi on the list, which is the following. And there's just 2 of them. I didn't use the F command, so I can't find out who they are, but I can see what terminal they're on and their process ID and so on. But getting back to just the basic PS, if I just type in PS like that, you might think to yourself, well, it is simply not possible to see anything other than your regular shell and the PS command if you type PS on the command line. In other words, you might think it's not possible to start any other programs at the same time. Well, I think if you recall that Sartori fellow, whoever that was, they had several programs going simultaneously. I wonder how they did that. Well, I'm going to show you in the next module how to start programs simultaneously, but what I will show you at the moment is, let's say I open up the program called Vi. We'll be learning about Vi in the next chapter. It is our text editor, and I will use it to edit a particular file, let's say another.txt. Okay, so we're now in the middle of editing that particular file. Now, would it be fair to say that in this current terminal session at the moment I am running a shell and I'm also running Vi? So if I was to do a PS at this point, which I can't do, I would find that I have running the shell and Vi, and of course I would also find that I was running the PS command. Now, this is something that you won't know about because you haven't seen Vi before, but it is possible within Vi to actually call up another shell. If I type in :sh in Vi, it actually starts for me another shell. And here I am now running another shell. So what's actually happening here is I've got my original shell running, and then I've used that to start Vi. And then within Vi, I've actually temporarily suspended Vi. Well, Vi is still running, but I've actually obtained another shell. I haven't dropped back out to my original shell. I've got a second shell running. And if I use that shell to run the PS command, I can prove that all of that is true. Now you can see that I'm running a bash followed by a Vi followed by a bash followed by a PS. And if I use the PS -f command, I can use their parent process IDs to trace the fact that the PS was started by this bash, and this bash was started by this Vi, and this Vi was started by this shell. Well, they were all started by me, but that's the way the processes created themselves. Now, of course, when I exit this particular shell, I drop back into Vi, and if I quit out of Vi, then I drop back into my original shell. I'll show you a little diagram of how I like to think of that. It's useful to think of this as a process stack. You start with your basic shell, which is the shell that you log into, and then you use that shell to start another program, say Vi, and the way you think of it is that you load Vi in on top of the shell. Now, you only are interacting with Vi at this point. The shell is still running, but it's kind of on hold while you're interacting with Vi. Then, as I showed you in the last example, I can use Vi to start another shell, which is loaded on top, and so temporarily Vi is put on hold while I interact with the shell that I've just used it to start. And then in that particular shell, I can say run the PS command. When the PS command finishes, I'm back at my original shell. Then I typed in exit to that shell, and that shell went away, and I was left with Vi. And when I decided to end Vi, that went away, and I was left back with my original shell. Incidentally, if I got rid of that as well by typing exit, then I would be left with no processes, and I would be back to a login prompt. But the way that these processes are loaded on and taken off is very, very similar to a stack, like a stack of books or a stack of boxes. You load them on top and then you take them off. You can't pull ones out from underneath. You're always interacting with the top one. That's why the term stack is actually a technical computer term, and it is used in this sense quite well. In the next module we will learn how to start processes simultaneously.